do it.
We'll first quickly revise that and then we'll see what we have planned for today.
Okay.
So whatever it is, for example, if the number is 333 and then we have 555. So whenever we are asked to find a cube root, so this is what we do. We make sets of 3. When we are asked to find square root, we make set of 2. So we'll be left with 3 cube times 5 cube, whole cube root. That is 3 times 15 cube root, and 15 is the answer for this particular question. And let me see what was question 6F. That was 1.1. Okay. I think this was the one, 6F.
Yes.
So it says use the product of prime factors to find the cube roots. So we make pair of 3s. So these are 3, then another 3, another 3, another 3, and another 3. So I have like 2 cube, 3, 4, 1, 2, 3, 4, 5. And this is 5 times it is there. So that is basically 1, 2, 3, 4, and 5 cube root of this. 2 times is 4, 2 times 8, 2 times 16, 2 times is 32. So cube root of 32768 is 32.
Okay.
So we may select any of them randomly and make pairs of 3. Any other issues in the task?
No other issues.
Okay. So we are one exercise short of this chapter, and then we can jump on to number 2, that is estimation. What do you know about estimation?
Estimation is basically using um like you're looking at what is given you and trying to get a result out of it without like the full information on it. Like an educated guess, maybe?
Okay, that is if I would have asked that, what do you think the answer would be? Or you're making an estimation that it is close to it. That is one perspective, that's right. In this scenario, when we are dealing with numbers, estimation is like the close value. For example, if I say that um, rounding up to the given degree of specified number, decimal places, or significant figures. Let's go through few examples. For example, if we are talking about rounding, so if I write 7.6, may I write that this is approximately equal to 8?
Yes.
And if I write 7.4, that is approximately equal to 7.
Mm-hmm.
So when do we round off? When our digit is either 5 or more than 5. Then we round up. This is round up. That is round down. So 5 or more than 5. So This was the last exercise from this chapter, and then we'll be completing it. It says round this to the nearest whole number. Is this number clear?
Mm-hmm.
64.839906. And to the nearest number, what should it be?
65.
Correct. One decimal place.
64.8.
Correct. Three decimal places.
64.8. 8, 4.
Correct. This 9 is rounding this 9, and that rounds the other number again because we cannot write 10 in that place. So no issues in rounding. I think we can directly jump to exercise. You know the topic already.
Mhm.
And let's zoom in a bit. Okay, much better. Okay, number 1 says round each number correct to 2 decimal places. So answer for the first one would
8.19.
correct 8.1.
Would it round to 1 as well?
No, we only do that when that's a 9 already and 9 changes to 10.
Okay.
What I do is always, like, you don't have to physically write this line, but I always do this in my mind. Examiner is asking me this, 2 decimal places. So I just draw this line in my mind and I write 3.1. Before writing it, I decide that if I have to round it up or no. That is 3.19. Answer was correct. What is this number up to 2 decimal places? G part.
0.01.
Correct. 0.01. Okay. 2 decimal places I part.
8.3.
Answer is correct, but we will write 8.30.
Okay.
Why so? To ensure 2 decimal places.
Okay.
Okay. So we have to just like we can't leave that blank. We have to show that space. Express each number correct to 4 significant. Do you understand significant figures?
Yes.
Okay. Tell me how many significant figures are these? 12. How many significant figures?
2.
That is 2. 120.
2.
If you say 2, that is correct. If you say 3, that is also correct.
Okay.
1200.
4.
That is 1200. 1200. How many significant figure are these?
4. 4 significant figures.
Yeah. So if you say 2, if you say 3, if you say 4, all 3 answers are correct. How is that happening? For example, we have a number 6. Let me say this is my answer. 6012. This is the question. And I ask you to round it to one significant figure. What would it be?
Mm, 6,000.
6,000. That's correct. Question number 2. If I have this question 6012 and I ask you to round it to two significant figure, what would it be?
6. Hmm.
Take your time.
6,010.
Two significant.
2 significant. 6,000 still?
6,000. Still, if I have this question and I ask you to round it to three significant figures, what would it be?
6,000.
6,000. And if we have last one, if we have this as 6000.4 and we round it to four significant figures, what could it be?
6,000.
6,000. So when you look at 6,000, it could be 1SF, it could be 2SF, it could be 3SF, it could be 4SF. When a digit is given, a number is given, something is there, something is present. So it has a significance. It was 6,000. This is units. This is tens. This is hundreds. This is thousand. Every single digit has its significance. So yes, we can say it is rounded to 1SF or 2SF or 3SF or 4SF. All four perceptions are correct. But whenever the examiner states so, that round off the given number to a particular significant figures, we have to respect that. For example, 703,159. If I say round it to one significant figure, may I write it as 7 and 5 zeros?
Yes.
If the examiner tells me to write it to four significant figure, this is the line in my mind. And I would write 703. Before writing 1, I would see if that rounds off. Yes, it does. 0, 0. That would be four significant figures. So in case when we are given 703,159, how many significant figure is this?
6.
Correct. This is surely six significant figures. In this case, we cannot say 1, 2, 3, 4, 5, or 6. This is perfectly six significant figures. But when there are zeros, we cannot decide. So in this case, 1, 2, 3, 4, 5, or 6, all answers would be correct.
So if there's
Clear?
more than one zero.
This zero is actually between the numbers. There's no ambiguity.
Oh, okay.
There's no confusion. But when suppose I tell you that the price of something was 7,000. So you're not sure if it is rounded or not. But what if I tell you 7,213? So I'm very sure why I'm telling this. I read it somewhere. And the listener would also agree that this is a very exact price. I would say approximately 7,000. So you're not sure what was the degree of rounding. Either the price or maybe it would have been 6,999. So we could say it is one significant, two, three, or four, anything.
Okay.
If I just round off this figure, 6,999 to 1SF, would it be 7,000?
Yes.
And again at 2SF, again at 3SF. For four significant figure, yes, it is it. Unless until we look at the decimal numbers, how many cents or how many pennies there were. Getting it?
Mm.
Okay. So express each number correct to whatever the question states. This degree of accuracy. First, we are talking about 4, then 3, then 1 again. So we'll deal with one number at a time. This is 4512 up to four significant figures. What would it be?
4512.
Correct. 3SF.
4510.
Correct. 1SF.
5000.
Correct. I part. 4SF.
What is it? 0.00998.
Mm, sorry, what did I ask? 4 or 1?
4. Oh.
4SF in this case, if we have to write four significant figures, that would be 0.009. This is the first significant digit. And 9 and 8 and 0.
Oh, I need to add the zero. Okay.
Yeah, to complete those digits.
Okay.
And what if we talk about one significant figure? Let me clear this writing space. Again, for this one significant figure,
0.01.
0.01. Correct. In this case, if we are adding or not adding these zeros makes no difference. So we can write 0.01. That's correct. Okay, change this to decimal using your calculator. So no issues. We can skip that. And unit 1 is complete. Let's move on to unit 2. And I'll share some questions from 1 and part of 2. That would be a bit longer considering that we have a next class in 5 days. Okay.
Okay.